Okay, welcome. This is the Navigator and Scout safety briefing. Let me get the screen shared. There we go. Okay, so in this briefing, we are going to go over the initial safety inspection document, although I don't think any regionals require documents to be turned in early for an initial safety inspection for Navigator and Scout. We're going to go over the process for your on-site safety inspection, and then we're going to go through some examples with photographs of what will and will not pass inspection. So for the initial safety inspection, and as I said, most regionals, I don't think any regionals require teams to turn in any safety documentation early before competition day. But if they do, your regional coordinator will let you know. You can contact your regional coordinator or check out your regional's information page for more information on this as well. But if you are required to turn things in, you'll need to turn in your SIDs, or you can turn them in on competition day. And that includes an ROV SID, electrical, so all the electrical systems of your ROV, a non-ROV SID if you're doing task 3, mate floats, and you have a float. And then if you're using fluid power, hydraulics, pneumatics, you'll need to turn in a fluid power SID as well. And of course, these documents will be looked over by your safety inspector. A little more on SIDs. Your ROV electrical SID is an overview of how electricity flows through your ROV systems, from the power source through a fuse to your controls, down the tether to your motors and other systems. And this allows a safety inspector to get a quick idea of how your ROV works. Creating a SID is also great for students to better understand their ROV. Students can understand how things work in their ROV, how systems work, what systems are connected to others, and how electricity flows through the system. Make sure on your SID to know what components are on the surface and what components are on the ROV, which is going underwater. Now make sure to have a fuse on your SID, and the fuse should use a proper fuse symbol. We're going to talk a little bit more about that later. And if you are using fluid power, hydraulics or pneumatics, there must be a SID for that. So if you are using simple hydraulics or pneumatics, essentially hand-powered manual, a syringe, that's pretty simple. You can add that to your main SID, mainly just a line connecting a box on the surface to a box on your vehicle. Now for navigator teams, if you are using a higher end system using an air compressor, you do need to include a full power SID, and all the symbols on a fluid power SID should be using industry standard symbols. Okay, let's talk about the on-site safety inspection. On competition day, you will undergo an on-site safety inspection. If your competition lasts for multiple days, it may be the first day you go through this, and you probably won't have to go through one again on the day 2. But again, that's something you can talk to your regional coordinator about. But you will bring your ROV and any other systems, including a float if you have a float, to a safety inspector, or they may come to you. It all depends on how the regional works, and they are going to run you through the safety inspection. Now, if they find an issue, they're going to let you know what that issue is, and you can get your ROV back. You can make that fix, and when that fix is done, you bring it back, and the safety inspectors will look it over again. Now, if there's another issue or you didn't actually fix the first issue, the judges will let you know that. And especially after the second inspection, the inspectors, they're going to work with you and say, hey, here's how this needs to be fixed. So it won't just be like, hey, here's an issue, go fix it. They're going to say, why don't you try doing this? So when you come back for that third and final time, you're not going to have any issues. So here are some examples of safety violations or something to think about beforehand and to avoid. You need to use Anderson power pole connectors or red-black Anderson power pole connectors to attach to main power. You need a SID, talked about that. As I said, your SID must have a fuse shown on it, and it must be industry standard symbols. If your ROV uses pneumatics, you need to include a SID for that. Sharp items or potentially sharp items like glass bottles, or fishing hooks, those should never be included on the vehicle. The vehicle motors need to be waterproofed. If you're using bilge pump motors that come with a CMate kit or that you've had, those are waterproofed, but all systems, including the motors, must be waterproofed. Your propellers need to be protected inside the framework or shrouded. And for Navigator class teams, the propellers must be shrouded to IP20 standards. And that means that a half-inch dowel, 1.252 centimeter wooden dowel, can't touch any propeller. So the safety inspectors are going to probe around. They're not going to be pushing too hard, but probe around and make sure you're properly protected. And that's for Navigator. For Scout, you just either need your propellers inside the frame so that if you bump up against something, a wall, a diver, that spinning propeller is not going to do any damage. And then another common thing is teams, if your camera needs to operate off the Mate 12-volt system. So when you plug in to your red, black Anderson poles, that should also power your camera. You can't power your camera from any other places. Okay, so the competition safety inspectors, they are going to be using the safety inspection score sheet to evaluate you. If you want to know exactly what they will be looking for, you can look at and read the score sheet. It's going to be posted on the Mate website, either under Navigator or Scout. You can look for your on-site safety inspection sheet, and that'll go line by line through everything those safety inspectors are going to be looking for. So make sure you read that, look through that, and just make sure that you meet all those checks. And what I recommend is having your mentor, a parent, a teacher, run you through a safety check a couple days before the competition, or even a couple weeks before the competition. Just have them run you through that while you're there, and they can look for issues. And of course, if you find any, you can fix them well before you get to the competition. Okay, so here are the checklists. Kind of hard to see here, but again, if you go down here to scoring, you can find all these. Are also this is a Scout one. It's on the Scout page. Here is the Navigator one, and again, you can find these online if they're not posted. When you're listening to this, they should be soon, so just check back to see when they are posted. Okay, so let's talk a little bit about Task 3, Mate Floats. So if you plan to undertake Task 3, if you have a float, you do need a SID for that float. So when you get to your safety inspection, you're going to want to hand them not only a SID for your ROV, but a SID for your float to do. And so to make a SID, here's a little hint. In all likelihood, maybe not, but in all likelihood, your profiling float is essentially going to be 1/3 of a simple ROV. It's going to be an ROV with only one motor that takes you up and down. So look at your ROV SID, look at it and go, hey, what can I take off of this? What do I need to add to this? Probably not add to this, but what can I take off of this to make a float SID? Now, for your temperature probe, that's pretty easy. Most often, you're going to have a readout up top plugged into a power source, or it might have a battery. Then you're going to have a tether, and then you're going to have a temperature probe on the ROV. For a SID, that's all you need, a little box up top with the power source noted, whether you're plugging in to Mate power or it has a battery on it, a line for the tether, and then a little box on the ROV that says temperature probe. And that's it for your SID for a float. Can't get to my pages. Okay. And the last thing I want to add about that is for your temperature probe. Yes, it can be powered from a small onboard battery if it comes that way off the shelf. We don't want you to like, hey, it came this other way, but we made it run off a battery. So if it's one of those that has a little button battery or other battery inside it, that's fine. That battery does have to be 9 volts or less. But a lot of these small thermometers come that way using a button battery, and that is just fine, provided that stays on the surface. That battery shouldn't go in the water. Okay, so let's look at some examples and photos of items that will and will not pass a safety inspection. Okay, number one, everything must be secure to the ROV, nothing loose and dangling by a wire. And so you can see over here on the left, that camera's just loose and dangling. Well, this one is more secure. And I will say that when I do safety inspections for teams, I generally pick up the ROV and just give it a gentle shake. I'm not shaking it hard trying to break anything loose, but I just want to see that everything is secured on there. Now for navigator classes, if you are using, let's say, a larger monitor for your video feed, make sure that is secured to the table as well. That is part of your system. You don't want it falling over, so you want to make sure that is secured as well. So no sharp edges or elements of the ROV design that could cause injury to personnel or damage to the pool surface. So on this picture, you can see there are some spikes out front of these. I have no idea why they put these spikes on here. But again, they, as far as I know, don't serve a purpose and they are sharp. So no sharp edges. You don't want to use like fishing hooks or anything like that to pick things up. Now, if you had more of a grappling hook that doesn't have a sharp edge, that's fine, but nothing like a sharp fishing hook. And the same goes for glass. If you had a glass jar or a glass thermometer with inside it to try and do temperature, that's not allowed because that glass could break, and then you have not only sharp objects on your ROV, but there's probably going to be some in the pool that would be really hard to see. So no glass goes into the pool, and you probably shouldn't have any glass on the pool deck either. And again, for navigators with a monitor, just make sure that monitor is secure and doesn't have any glass that could break. A few years ago, we did get a team with some really, really old monitors that actually had an actual glass front to them, and that wasn't allowed because, again, that can break and cause sharp edges. Okay, so let's say you need something sharp to complete a mission. Now, for Navigator Scout, I don't think there's anything this year where you need something sharp, but just in case it is, or you do decide you need something sharp to complete a mission, make sure that that is noted and colored in a protective way. So here you can see their sharp little edges. They made red, kind of protected it in this circle, and then a bigger circle here with their yellow back, kind of yellow black safety indicator. So essentially everyone knows, hey, this is a potentially dangerous area. If you're interacting with this, be safe. And if a sharp is required, be able to explain to the judge why it is needed and show the judges how you called this out and made it safe. Okay, so let's talk shrouds for navigator class. Again, this doesn't apply to scout class. And as per the rules, you must shroud all your motors to IP20 standards. That means nothing larger than 12.5 millimeters, 1.25 centimeters, which is about half an inch or so, can touch a propeller. So safety inspectors, as I noted earlier, will usually have a half-inch wooden dowel or something like that and try and poke it into your shroud. And if that half-inch wooden dowel can touch a propeller, and that's from any angle, it can come in from this angle, underneath. Here you can see the underneath of this, any angle. If it can touch a propeller, you have not shrouded it to proper specifications and you won't pass safety inspection. So there are shrouds you can 3D print. This one, you can see this was a 3D printed shroud. This is from the Eastern Edge Robotics team. You can build your own out of something else. Just be sure, however you do it, that that half-inch wooden dowel can't touch a propeller. And again, that's something you can practice, or when you have a instructor, mentor run you through safety, have them do that, have them check to make sure all of your propellers are shrouded. Now, for scout class, propellers can be shrouded or they can just be inside the frame. So in this one, you can see, lots of duct tape here, but this propeller and this propeller are shrouded. They are inside these plastic cups or plastic circles, so that if this ROV bumps into something, that turning propeller isn't going to touch the side of the pool, the leg of a diver, or anything like that. And that's the goal for the scout class. If it bumps into a wall, if it bumps into a diver, if it bumps into a mission prop, that any turning propeller will not touch that wall, diver, mission prop, or whatever. Okay? So let's move on to attachment to power source. You are required to have Anderson power pole connectors. So these red-black connectors, That's how you're going to plug into whether it's a power supply, a power pack, a 12-volt marine RV battery. You're going to connect to power through this red-black Anderson power pole. Here you can kind of see how they fit together here. The plastic here has this little metal tab, and then this goes over that tab and presses down. So you get this metal to metal connection in multiple places here. So if you are doing this on your own, just make sure you get them in. And when you push them in, you will hear a snap. And give them a test. Give them a pull back out, because if you have a loose or an intermittent fault, it can cause some issues. Okay, a little more on Anderson power poles. If you are doing this yourself, you want to include a proper crimp. So your standard crimpers aren't going to work. There are specific Anderson power pole crimpers that you want to crimp this little metal end onto the end of your wire. So use those so it kind of gets this nice, what's called a roll crimp, not your typical kind of squishing together of things to crimp it. Okay, so let's talk a little bit about fuse symbols on your SID. As I noted earlier, for your fuse symbol, you must use a proper ANSI, NEMA, or IEC symbol. So here they are. You can see the four essentially fuse symbols you can use. They are also shown in the manual. So if you want to look there, you can get them from there. And if you just go online to Google or something and proper fuse symbol, you should be able to get any of these so you can use them in there. And so use a proper symbol. Don't try to approximate one, especially this one. I will admit, when I started, I just used an S, turned it on its side, and stuck it in there. A letter S, that's not a proper fuse symbol. So use one of these proper fuse symbols. So here is an example of a SID. This would kind of represent a triggerfish or barracuda ROV kit. Now, a couple things on this one. I would probably have these together. These are a little separate right now, and I would have that red and black together because that's how they have to be. Has a fuse symbol there. Yep, so there's the fuse symbol. And essentially what we're looking for is, it shows how things are connected, and it also shows what's above the water line. So everything from this side is above the water line, and the four motors and the camera are underneath the water line. So this is an example of a SID that represents more of a pufferfish or angelfish ROV kit. Essentially, you have three switches controlling three motors. It shows your power source, it shows your fuse, your switches, the motors, and then the cameras. And again, you can see what's underwater is the motors and the camera, whereas your video monitor, switches, and all this is topside. So this is kind of what a safety inspector wants to see from your SID. Now, one thing to add is don't just copy one of these SIDs. Don't take the one that's in the manual, or don't take this one, cut and paste it and use it as your own. You are required to make your own. Now, you can make it look a lot like this, but do make your own. If a safety inspector, some of our safety inspectors, if they see this, they're going to know who made this and say like, hey, nope, you need to make your own. So definitely make your own SID. Okay, so some of the other things. Single Anderson PowerPoint connection to power, and the fuse within 30 centimeters of that. So this does have a fuse. You can see the fuse over here, but this is not a proper connection. Number one, they're using banana plugs instead of the Anderson power poles, and they actually have three plugs plugged together here, and only one of these lines goes through the fuse. So if you look at this on the reds, the power, this one goes through a fuse, but these two do not go through a fuse. So this would not pass. Number one, not using banana plugs, we're using Andersons, and everything needs to go through a fuse. So in this case, what you do is you have your fuse in line, and then after that fuse, then you can split off to however many wires you want, go to whatever systems you want on your vehicle. So this, as I said, this is really what I want to see. You have your Anderson connectors here, short bit of wire, then you have your fuse. And again, What you do downstream of this is up to you. This is what we want to see. Connection, fuse in there on the positive side, and then what you do downstream of that is up to you. Okay, no exposed copper wire or bare wire, no exposed motors. Kind of the same thing. Motors that aren't waterproof might not be able to see it, but there's a lot of exposed copper in there. So these little motors, I've seen them used long in the past, but you don't want to use these in the water. Um, in good fresh water, they'll actually work, but they are not waterproof. And same with this, even putting tape around this, that's not waterproof. So use a good waterproof motor. And so not talking about motors, but just exposed copper in your control box, just make sure that, you know, when you strip that wire and put it into a port or put it into a terminal pin, that there's not a lot of copper sticking out beyond that port, beyond that terminal pin. Now there might be a little bit being able to see, but you don't want so much that if it can get touched by another wire, because if you have two copper wires touching, you could short something out if they're not supposed to be touching. Okay, this one, again, no exposed copper or bare wire. Inside your control box, we don't want you to use jumpers like this because they can come loose, and if one of these comes loose and is kind of rolling around, jumping around inside your control box, that is going to be a safety issue. That could cause short. So don't use kind of these banana plug jumpers. You want to really secure your any jumpers you have in place. So the tether is properly secured at the surface control point and the ROV. So strain relief, both at the control box and on the ROV side of the system. So this is a control box, and these are great strain reliefs. As you tighten these up, they will tighten around the tether, tighten around whatever wires are going in or and out of the control box, and really keep those secure. Whereas this one, there's nothing here. So if they pulled on that, on this tether, which is going to happen, it's going to pull either directly on the solder joints where they soldered things together, either in, it looks like in this mess, or they're going to pull right where the wires are going into the motor. So really what you want to do is if that tether gets pulled on, either at the bottom end or a wire gets pulled onto the top end, that it is not pulling on any connection you made. It's pulling on your control box, or it's on the entire ROV frame, not pulling on any connections. Okay, so here are some examples of not sufficient strain relief. This is an old picture, but we used to just have it where the wires come out and you kind of tighten them down. This is not sufficient. If you pull hard enough on these, they're gonna slip and come out. So you don't want to do this. You want some actual strain relief in here. Strain relief glands like this are, as I said earlier, these are fantastic. As you tighten these down, so as you tighten this, turn it clockwise, it squeezes down inside, so it makes a good connection against the wires here, so that if this wire gets pulled on, it's pulling on the gland, which is attached to the entire control box, instead of pulling on the connections. And same for this one. This one just has a pigtail attachment, but again, as you turn this clockwise, it locks down over this tether wire and keeps it from pulling on any connections. Whew, a lot of bad stuff here. So number one, these are the old style monitors. I think these might have glass covers, which could break and create sharp edges. There is a lot of exposed copper here. Sides of the fuses. There are alligator clips running everywhere, which again could come loose. And if the hot end that comes loose and is bouncing around your control system, you don't know what it's touching, where it's providing its power. Alligator clips have strain relief issues too. If those wires are pulled on, if I'm looking at this red one here and this green one here, well, that green one's not alligator, but if you pulled on this one, you're pulling directly on a connection. So there's no strain relief here, and mainly just no wire discipline. Who knows where these wires are going? There's just this big rat's nest. They're using AC over here, but it's not clearly marked, clearly delineated what that AC is going to. So, a lot of problems with this. And what I recommend is check out the link here, the mate expected work practices, and that has more on wire discipline, what you want to do to avoid something like this. And it goes over wire discipline, connections, and more. So let's move into fluid power for Scout class or for Navigator class if you're using manual pumps only. The questions are, is there a pneumatic or is there a pneumatic hydraulic SID present? So is there a SID for your fluid power? Are you using a hand or foot pump only? A syringe that would count as a hand. You might be, stepping on something to push air down a line. Um, is your fluid you're using air or water? Don't use anything else. We don't allow hydraulic oils in the pool. Don't use anything other than air. Um, are you pressurizing a container? This is not allowed for Scout if Navigator. There are some rules if you are pumping air into a container. And if you and that's for a container without any exits. Now for if you do want to pump air into a container, this is for both classes, you want to have at least 1/4 inch hole in the bottom. So that as you pump air in, it displaces the water. The water can go out and you can move that as you pump in air. It can help you move up. But that water needs a place to exit and the air. If you pump so much air in there, it pushes all the water out. That air needs a place to exit. So you need at least a 1/4 inch diameter hole, for instance, in the bottom of your container, and then you can pump the water out, fill it with air, and that'll give you some lift. For Navigator class, if you are using pressurized fluid power, if you are using a pump, this is what you want to do. So, sorry, if you're using a compressor for air, number one, you must pass the fluid power quiz. You need a SID for this, and all your systems, all your elements need to be on that SID. You need to provide the specifications for that components, for all your components. So the hose line you're using, it needs to be rated to 2.5 times the maximum allowed. So all your components need to be for air at least to be rated to 100 psi. You're allowed 40 psi and 2.5 times that 11. So make sure everything is rated for that. Make sure your attachment to the pressure source is secure. Again, as I just mentioned, you are limited to 40 psi max for pneumatics and 150 psi max for hydraulics. You have to provide the regulator. So Mate is not going to be providing any of these components. You need to provide them for yourself. If you have a pressure accumulator, you need to have tested that and provide the test results. You don't want any hydraulic fluids leaking, and just make sure you're using air or inert gas. And again, Mate is not going to provide compressors at regional. Your regional might. So again, you can contact your regional, but in general, regionals are not going to be providing compressors. But you can click on this link to see compressed air guidelines for what we require at the World Championship for Ranger teams if they are using our compressors. And that's just going to help you figure out how you should set up your compressor, what components you should have in your system. Okay, lastly, for lasers, again, this is Navigator teams only. Look in the rules, there's a lot of specifications. But number one, teams need to send their laser specs and their laser glasses specs. You need to have laser safety glasses to the competition technical manager. That's me. You can find a link to that in the manual in the laser section at least 2 weeks prior to your regional. So I will give you the okay, and I'll also let your regional coordinator know that you are okay to use a laser. So send it in plenty of time so you can get those results back, and I can get that to your regional coordinator. If you have a laser, your SID needs to show the laser driver, the laser power source. How are you powering it? And again, onboard batteries are not allowed for this. Your laser needs an on-off switch on your surface controller, so you need some way to turn that laser on and off. It needs to be powered from the Mate power supply. So again, No onboard batteries or no batteries powering this laser. Um, that's the next one too, no batteries. Your lasers need to be of a certain type. I'm not going to go through all this, but make sure it's a certain type. And when you send in your specifications, make sure this is on there. Send the link. It's like, hey, here's the laser I'm looking to get, and make sure it has all these specifications in it. Um, and again, send that to me. And and now down here, does your laser, does your ROV and laser have a shield or beam stop? So what you need is something in front of that laser that when you're in the water floats up out of the way so your laser will work. But when it's on the surface in the air, that's a beam stop. So that laser cannot go more than 30 centimeters. And this shouldn't be something you're taking on and removing by hand. It's something that should happen automatically. And then again, all team members need to have laser safety glasses regardless of the laser output used. So yes, you know, a lot of people are like, oh, these lasers are pretty harmless. And yes, that's mostly true, but we still want you to be safe with lasers. So everyone on your team needs laser safety glasses. Okay, so that is it for this briefing. In conclusion, I just want to say we want all teams to think about safety. So our goal is not to use safety to fail teams in their safety inspection and eliminate them from the competition. If you fail your first inspection, our inspectors are going to work with you to make sure you solve those issues. And again, if you fail that second one, they're really going to work hard with you to make sure you can pass that third one. And I'll also just say that all of our safety, we work with industry to align our safety specifications to industry standards. So we work with a lot of groups in industry and have them work with us on all these safety rules. And we want our students to be familiar with industry standards because hopefully many of you students may be out working in the industry one day. May still be a few years for you on Navigator Scout class teams, but we want you to be familiar with the industry standards so that they're second nature when you're out in the workforce. And again, if you do go into this industry, might help you get a job when they talk about safety. You're like, oh yeah, I did all this safety stuff for my ROV and we did this, this, and this. They know that you are familiar with their safety standards. As for safety for the competition, if you have a question, ask. In this case, it's better to ask permission than to show up with something unsafe and ask for forgiveness because you're not going to pass safety inspection and then you're going to have to fix it on competition day, competition morning before you get in the water on your first one. So again, if you have a question about whether your system meets safety, ask. There's a mate Q&A forum board. It's linked to here. You can also find the links in your manual, and you can describe your system to the competition technical manager. That's me. I'll look it over. If need be, I'll discuss it with our lead safety inspectors, and we will get you an answer. Either yes, you can use it, or hey, you know, you might want to do something else, or here's how you could modify it to make it safe. So lastly, think safety. Good luck. We hope to see everyone having a fun, safe time at your regional competition. Thank you.